All right, we'll continue with the exam review, and today we're going to focus on chapter 4. This is where we started to talk about trigonometry and the unit circle. First example is a trig equation. It's an equation because there's an equal sign. Our job is to figure out all the angles between 0 degrees and 720 degrees that would solve this. And my first move will be to subtract 1 from both sides, or move the positive 1 from the left to the right. My second move would be to divide both sides by the square root of 3. And there's what I'm left with. Now you can write that as a decimal if you like, or you can leave as is. We're going to move on to finding our reference angle. So step 1 is to find theta bar. And remember, theta bar in this case is going to equal the inverse tangent of the absolute value of -1 over root 3. Anyone want to do that? Anyone know what it is? It's 30 degrees. How do I know it's 30 degrees? It comes from this triangle right here. It's asking you which angle has a tangent value of 1 over root 3. It's that angle right there. The opposite side is 1 and the adjacent side is root 3. But if you pump that into your calculator, what do the absolute value bars tell you to do? Make this a what? So just do the inverse tangent of 1 divided by root 3, put it in brackets, hit enter, you should get 30 degrees. Step 2 is to figure out which quadrant you would be looking in, or which quadrant are your answers in. So sometimes we ask this question, where is theta? We'll look at our cast rule. And I'm going to focus on this sign right there. That means tangent is a negative. It's less than 0. If tangent is positive in the first quadrant and the third quadrant, it would be negative in the second and fourth. You follow? If this was a positive 1 over root 3, this would still be 30, but I'd be looking in quadrant 1 and 3. Step 3 is to find theta. Find the actual angles. Well, in quadrant 2, we have a formula. You will be given these formulas. The formula for quadrant 2, I'll just get rid of this guy. It says theta is equal to 180 degrees minus theta bar. What was theta bar? Was 180 minus 30. 150. In quadrant 4, theta is equal to 360 minus theta bar. Or 360 minus 30. 330 degrees. Now I can test these answers. If I take my calculator, make sure it's in degree mode. I'm going to do the square root of 3. I'm going to hit the tangent button. I'm going to fill that angle in, 150, close the brackets, and then I'm going to add 1. And if I do that, what should I get? If it's a solution, what should my calculator say? 0. Boom. Good. I could try 330 as well. Fill a 330 in for theta into the original and try and prove the left side equals the right side. The tangent of 330 times the square root of 3 plus 1 also equals 0. The last move is to find any coterminal angles. Angles, and they have to fit between this domain. They got to be greater than or equal to 0 degrees, but less than or equal to 720 degrees. How do you find coterminal angles when you're in degrees? You add or subtract multiples of what? 360, full revolutions, full rotations. Would it make sense to subtract 360? 150 minus 360 gives me negative 210. Yes, it works, it's true, but it doesn't fit between 0 and 720. Don't want to subtract 360 here and get negative 30 either. It's too small. What should I do to these? Not subtract 360, but add 360. 150 and 360, that's 410, that's 510. Does 510 fit between 0 and 720? If I plug 510 back in here for theta, it would work out to be a 0. The tangent of 510 times the square root of 3 plus 1 equals 0. And I'll do 330 plus 360. That gives me 690. How many angles do I have, or how many answers? 4 of them. Okay, you can just circle them, or you can say theta equals 150, 330, 510, and 690. Should I add 720? Should I add another rotation, or add 360 again? No, it's going to give me something that's too big. It has to be less than 720. So you can't add 720 to these numbers. That'll give you something bigger. Good with that? That's a trig equation. Let us look at the trig expression. This one's in radians. Everyone okay with that? Now, I don't want you to flip your calculator to radian mode and then solve it using your calculator. How do we solve these? What do we do? I drew each of the angles, 5 pi over 4, 5 pi over 6, and 4 pi over 3. So let's do that. How do I draw 5 pi over 4? I'm going to put it between 4 pi over 4 and 6 pi over 4. Do we agree that this would reduce to 1 pi? 1 pi is an odd multiple of pi. This is actually helpful too. It's 3 pi over 2. I know exactly where that is. When it comes to drawing my 5 pi over 4, I'm going to draw my x and y axis. I know exactly where this is. This is 4 pi over 4. That would point to the left. Odd multiples point to the left. Even multiples point to the right. This would be 6 pi over 4, or 3 pi over 2, sorry. So tell me this. Where would 5 pi over 4 go? Right in the middle, right between them. And that's in quadrant 1, 2, 3. There? Once you draw the angle, make your reference triangle with what axis? The x-axis. The next step is to find your reference angle. What's this angle right in here? How do I figure that out? I take this number, 5 pi over 4, and I subtract this number, 4 pi over 4. It's the difference between the two. 5 pi over 4 minus 4 pi over 4 would leave 1 pi over 4. Now I'm going to get rid of this stuff. And I'm going to move that out a little so I have some space to work. With me? Once you get your reference triangle, or your reference angle, sorry, label the other angles. So this would be pi over 4. And then label your side lengths. X, Y, and R. Now on the board, on the chalkboard, it says 1, 1, and root 2, right? But let's add some direction here. What should my X value be? -1, and my y value is also a negative. Remember how it works. Across from the pi over 2, across from the right angle is the root 2. Across from the pi over 4 is a 1. Across from this pi over 4 would be a 1 as well. Why are they negative? Because I'm moving left and down. And then I'm going to evaluate the tangent of 5 pi over 4. I'll worry about squaring it in a minute. The tangent of 5 pi over 4. Well, remember, tangent is y over x. Look at what you labeled or you drew there. The y value is negative 1. The r value is root 2. Some people like to square it now. That's fine. If you square it, you'd end up with a half. I'll do that in a minute. Good there? Now I'm going to draw 5 pi over 6. 4 pi over 6. 5 pi over 6. And 6 pi over 6. 6 pi over 6, that reduces to 1 pi, which is odd. This reduces to 2 pi over 3, but that's not really helpful. If I don't know where 5 pi over 6 is, I don't know where 2 pi over 3 is either. Let's draw our x and y axis. There's the y axis. There's the x-axis. Everyone okay with the 6 pi over 6 pointing here? Where would 5 pi over 6 be? In quadrant 2 or quadrant 3? Is it more or less? It's less. It's in quadrant 2. Now, if you wanted to be precise, you would draw it like that. For the sake of our question, I'm just going to draw it in here so I have some space. And another way to do this would have been to go 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Just break the top into sixths or break the whole thing into twelfths. All right. Draw your reference triangle with the x-axis. Tell me what the measure of this angle is right here. Subtract the smaller from the larger. What's 6 pi over 6 minus 5 pi over 6? 1 pi over 6. Good? Let's get rid of these now. And remember your special triangle. Pi over 6, pi over 2. This angle up here would be pi over 3. I've got x, I've got y, and I've got r. The biggest angle is across from the biggest side. The smallest angle, pi over 6, is across from the smallest side. And the middle angle, pi over 3, is across from the middle side. Now, any of these positive or negative? The root 3 is a negative because you're moving left. The y is a positive because you're moving up. And the r, the resultant, is always a positive. Which trig ratio am I trying to solve for? The sine of 5 pi over 6. Remember, sine is equal to y over r, or the opposite over the hypotenuse. The opposite is y, the hypotenuse is r. The sine of 5 pi over 6 is going to equal 1 over 2. Good? One more angle to sketch, one more expression to solve for, and then I got to put it all together. What's my last angle? Four pi over 3. It's between 3 pi over 3 and 5 pi over 3. This is the key. 1 pi again. Is it always 1 pi? Does it always work out like this? No. 5 pi over 3 is not helpful. I'll draw my x and y axis. I'm going to put the 3 pi over 3 pointing to the left. Odd multiples point to the left. Decide where the 4 pi over 3 should go. Is it more than 3 pi over 3 or less than 3 pi over 3? It's more. 4 is more than 3. So 4 pi over 3 would go here. Another option would be to go 0 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. 4 pi over 3 is in quadrant 3. Make your reference triangle with the x-axis. Figure out your reference angle. What's that angle right there between the purple and the blue? 4 pi over 3 minus 3 pi over 3. Pi over 3. It's the same triangle right here. It's just flipped around. If that's pi over 2 and that's pi over 3, this would be pi over 6. Remember how it goes. The largest angle, pi over 2, is across from the largest side. So the R value is a 2 in this case. The smallest angle, pi over 6, is across from the smallest side. So the 1 goes opposite to pi over 6. I'm going to make it a negative because I'm going left. The y value is going to be a negative root 3. The root 3 and the pi over 3 are always attached to each other. They're married. And then it's sine of 4 pi over 3. So once again, when it comes to solving, it's the opposite over the hypotenuse, or the y value over the r value. And that's going to equal negative root 3 over 2. What's that? I did. Okay. Colin Cassidy just made a very good find that would have screwed up our answer. The rest of us were sleeping. You didn't catch my mistake. I'm not going to lie and say I did it on purpose to see if you were paying attention. I really just made a mistake. He said when I did the tangent of 5 pi over 4, I wrote it down correctly. It's the opposite over the adjacent, or y over x. But look at when I went to my diagram. I wrote y over what? R. Nice catch. So that actually should be a negative 1 over a positive 1. Awesome. Thank you. Negative 1 over negative 1. Man, we're struggling. This is going on the internet too. That's going to be embarrassing for me. Good job no one watches. All right, here we go. I'm going to slide this down, and I'm going to show you how it all fits together. So negative 1 divided by negative 1, we know that to be a positive 1. Here's what I'm going to do. I'm going to write the 5, and then I'm going to change the tangent of 5 pi over 4 to a 1. And I'll square that. It's over 6 times. What is the sine of 5 pi over 6? The sine of 5 pi over 6 is 1/2. I've got a plus sign, and then a 4. And then what's the sine of 4 pi over 3? Negative root 3 over 2. Everyone okay with that? So I've just changed or swapped out or substituted each of the trig expressions with their corresponding values. What's 1 squared? 1 times 1. 1 times 5 would give me 5. What's 6 times 1/2? Like you could do that over here. It's 6 over 2, top by top, bottom by bottom. What's it equal? What's 6 divided by 2? Let me check that. It's 3. Thanks, Colin Cassidy. You're on fire today. What about this? This throws people off. That would be negative 4 root 3 over 2. Top by top, bottom by bottom. Negative 4 over 2 is really Negative 2 root 3. You with me on that? Now, when we did these, I asked you to express your answer as a radical in simplest form. And to do that, I would have to rationalize the denominator. So I would multiply both top and bottom by the conjugate of 3 minus 2 root 3. What's the conjugate of 3 minus 2 root 3? 3 plus 2 root 3. Watch this. That's 5 times 3. What's 5 times 2 root 3? Awesome. On the bottom, when I rationalize this, I should have no radicals left in the bottom. Check it out. What's 3 times 3? This would give me 6 root 3. This would give me minus 6 root 3. And those would go away. What's this? What's negative 2 root 3 times positive 2 root 3? Well, a negative 2 times a positive 2 is a negative 4. What's root 3 times root 3? It's 3. You could write 4 root 9 or 4 times 3. And then I end up with 15 plus 10 root 3 over this is 9 minus 12, negative 3. Yeah? And I would write that like so. Negative 15 minus 10 root 3 over 3. Or you could even write it as negative 1 times 15 plus 10 root 3 over 3. I can't do anything else with that. That's it. That's all. That's the show for today. That's chapter 4. Tomorrow we'll do chapter 5. Thanks for catching my mistakes and picking up my slack.